Hi, this is Chad for Monday morning, April 6th, and I am going to walk you through our first online lesson today. So this will be our normal format. You'll see two of these a week, and hopefully you'll be able to practice on Khan Academy after this. So I'm naming each one of these after its Khan Academy name. So you can just look up here, domain and range of a function, and then go straight to Khan Academy when we're done. There's also training available on Khan Academy. So if you don't understand what I'm talking about, you can go to Khan or every day after a lesson. So on Monday, I'll give this lesson, and then on Tuesday, you can join the live chat session. So I'll have a link right below this so that you can ask questions in a classroom setting. All right, let's go ahead and get started. The vocabulary for domain and range of a function are, of course, domain. Domain refers to all x values of a function. Allow me to move this out of the way. So if we look at this function that I have up here, this says total coronavirus cases in the United States. Our x values of this function go from February 15th to March 14th. Each one of these dates represents an x value of this particular function. So maybe my domain for here would be February 15th through March 14th. That is all of my x values. Domain and range. The range, you guessed it, is all the y values of a function. So again, if I'm looking at total coronavirus cases in the United States, my range is going to be going from 0 up to 4,000. So I'll go ahead and call this my range being 0 to 4,000 or 4K. All right, now there's two other vocab words that aren't in the title, but they are important. One of those vocab words is discrete function. I spelled it wrong here. It's actually discrete. Discrete function, a function whose xy ordered pairs have a clear separation between values. So this function right here has a line connecting all of the dots. It shouldn't. They don't continuously update us with information on the total coronavirus cases. The federal government actually gets a count once a day. So if we think about once a day, we really shouldn't have line segments connecting these dots. We should have a clear separation between values. So we get a February 15th, a February 16th, a February 17th update of the coronavirus cases. There is clearly a separation because we only get one data point per day. However, because they've connected the dots, it's a little misleading. It looks more like a continuous function. A continuous function is a function whose xy ordered pairs have no clear separation between values. Like connecting these dots would make it seem like we're constantly getting data. Every second of the day, we're getting a new number. And that in this case really isn't true. So this should be a discrete function with a clear separation between data points. However, because they connected the dots, probably just because it's a news organization and they're trying to help people see relationships, because they've connected the dots, it looks more continuous than discrete. All right, I'll be using those words throughout this. Okay, so this is our brief introduction to domain and range, x values and y values. And what I'm going to do next is I'm going to go through, oh, nope, I have one more example. And then I'm going to go through the problems that are on Khan Academy. Now, you know as well as I do, there's like 20 different Khan Academy problems. And what I'm going to do is just share 7 of them with you. So maybe you'll see the same, or maybe you'll see some different ones. But hopefully, if you see 7 of them, you can do the rest. Okay, here is another coronavirus graph, and I just thought I would take a look at it with you. So throughout this entire COVID-19 epidemic, we've been hearing this information that we're supposed to stay at home to flatten the curve. So this idea of flattening the curve is telling us that if we do nothing, then we're going to see this big spike very quickly in cases of coronavirus very quickly. So that the x-axis is talking about the time since the first case. So this would be day 0, maybe day 1, day 2. I'm not exactly sure what their interval is, but our domain for this would be something of this nature. The 0 would be the time of the first case indicated in the United States. And then when this ends up back on the x-axis, this would be like the very last case of coronavirus. It's probably actually going to end up being somewhat asymptotic. Like we'll have fewer and fewer cases, but there'll always be some. Um, so if we look at this type of graph, and this is if we do nothing, we just go about our daily business. The talk on the news has been that our range will be very high, so that we would have this being our y-axis, meaning number of COVID-19 cases. Our range would be very, very high. That this number, whatever it is, I think currently, as of today, it's 300,000. I put my comma in the wrong spot. That our range would be very, very high if we did nothing at all. Whereas if we stay home, we only go out when we absolutely need to, we don't congregate in large groups, that our domain would be a lot longer time. It would take a lot longer for us to perhaps get rid of the coronavirus because people aren't getting infected as quickly. It takes a long time for people to get infected, develop those immunities to it, and then get healthy. So it spreads it out. However, the total number of people, their range, would be much smaller. And if we can keep that range smaller, then we don't overwhelm the healthcare system. So this is the number of people that hospitals can actually treat with those ventilators, that they can use their personal protective equipment, their PPEs, like those N95 masks we've been hearing about, uh, in supply, that we're not running out of supplies. So we're trying to flatten this curve, take this curve, which would spike very quickly and overwhelm our hospitals and cause a lot of cases, and flatten it out. Stay at home, fewer people getting sick. We stay within our healthcare system's capacity, and people over time may be infected, but not with such quick rate. All right, so there's maybe a little bit of an explanation of what they mean by flattening the curve, how this relates to our math topic, which is domain and range. And now we go into Khan Academy. Okay, so when you get to Khan Academy, you're going to be looking for this domain and range from a graph. And the first thing I want you to notice as we go through these is it's going to ask you, what is the domain of f? So as soon as we see that word domain, we have to remember the vocabulary for domain. And the vocabulary for domain is all possible x values. So instantly, what I am doing is I am thinking about my x-axis, and I'm thinking, okay, where does this function, this goofy looking function, have x values? Well, it has x values that start at -5, and there's data all along here. So that means that there are x values at -4, -3, -2, -1, 0. There's x values all along here, and it stops at this spot. So all of these points on this weird shape have x values from -5 to 6. Because this is no clear separation of points, we call this a continuous function, and continuous functions have these compound inequality intervals. So what I'm looking for is something that begins at -5 with a solid dot, that is -5 is less than or equal to a whole bunch of x values, and then it stops at 6, again with a solid dot. So now I'm just comparing, and I see that this is my answer B. -5 is less than or equal to a bunch of x values in these ordered pairs, which is less than or equal to 6. All right, moving on, second one. Now I immediately look at this word. What is the range of G? I go into my thoughts of range, and my knowledge of range is all possible y values of a function. So now I'm thinking, okay, I'm only going to be concentrating on the y values. So as I look at all of these points, I think these points are clearly separated. This is a discrete function. I'm going to be looking at, there's a y value at 7. This point has a y value at 7. I'm going to look again, there's a y value at 3. That point has a y value at 3. I keep looking, this is the number -1. There is a y value of -1. A y value of -4, and a y value of 7. So I'm looking at all of these discrete points, and I'm looking at just their y values. And now I'm thinking, look for an answer that has -7, -4, -1. Don't forget that that's this guy right here. 3 and 7. This is a continuous looking answer. I know it's not going to be this answer because that's what continuous ranges look like. It's not that either. These are discrete values. I can clearly see a separation between their values. And as I look through, I see a -7, -4, -1, 3, and 7. So I know my answer choice is D. So far we've looked at a domain problem that was continuous and a range problem that was discrete. Okay, we've got a few more to look at. First thing I'm going to look at as I get on Khan Academy is, what's this word? What's the domain? I look at domain, I think about my vocabulary. Domain means X values. Then I look at my information and I say, okay, this is discrete. So I am looking at the X values in a discrete manner. And now I'm going to start, I just like to start on the left and work my way to the right. There is an X value at -6. It's this one. I keep going, there's an X value at this on the x-axis would be 0, -2, -1, 0. So I've got a -6, a 0. I can stop at 2 because of this one. I stop at 4 because of that one, and I stop at 7 because of that one. Okay, domain is X values. This is discrete. So I'm looking for a -7, 0, 2, 4, and 7. That's a continuous looking domain. That's continuous. That's discrete, but not the right information. And there we go. -6, 0, 2, 4, and 7. This is my X values. All right, moving on. Looking again at the most important word on this frame is this word right here. What is the range? Range means all possible. Whoa, I can't use a highlighter to make a Y, but I can put a Y right there. And now I look at this and I think, okay, all the dots are connected. There's no separation. So it must be that this is a continuous function. As soon as I realize this is a continuous function, I'm starting to think these are discrete separations. I'm not going to be choosing that. I'm not going to be choosing that. It's either got to be A or D. And how do I decide? I'm going to start looking at the very lowest y value. So this function goes all the way down to -6. That's the lowest it gets. And then I'm going to be scanning until I get the very highest y value. It looks like it's going all the way up to 1. So my eyes are taking me to the highest and the lowest, and everything in between. All of these points have y values that are between -6 and 1. So I'm thinking -6 is going to be less than or equal to all of my outputs. Since this function is h, my outputs are h of x, which is less than or equal to 1. This is my y values. Okay, -6 less than or equal to my outputs, which is less than or equal to 1. Looks like choice A. All right, so this was a range that was continuous question. Okay, moving on, I think we're almost there. I'm looking again at this word. What is the domain of G? Domain is all possible x values. I'm looking at this function. This function is definitely continuous. So now I'm thinking to myself, if it's continuous, I do not want a clear separation of points. I'm going to get rid of those. It's either going to be this answer or this answer because that's what a continuous domain looks like. And I'm going to look at the x values. So I'm coming over here on the x-axis and I'm thinking, okay, it starts here at -7, and then I've got a bunch of x values that keep going until it stops right here at 4. So I'm expecting to see something that says -7 is less than or equal to all of my x values. All of my x values are less than or equal to 4. So I'm looking up here, oh, and there it is, choice B. Okay, so what do you think of? As you look at this, maybe pause the video and think about the answer. Pause, think. Where does your mind go? Where do your eyes go? And I'll start. The first thing I look at is this word. What is the range? The next thing I think of, what does range mean? Range means all possible y values. I look at these dots and I think to myself, this is a discrete function. There's a clear separation of points. So over here, I'm now going to look and I'm going to say, well, this is what a continuous function's range looks like, and this is what a continuous function's range looks like. It's not continuous, it's discrete. So I'm looking for those clear separations of points. Range, y values, start looking at the y values. I've got a -4 here. I've got a -2 over here. I've got a 2. I've got a 4. And I've got a 6. So I'm looking for some set over there that says -4, -2, 2, 4, and 6. -4, -2, 2, 4, and 6. Choice A. Did you choose that? Good. I feel like Blue's Clues. All right, a couple more practice problems. I'll pause. Maybe you should pause the video. Think about it. Think about what you would look at. Think about the answer choices. And I'll start. Okay, I'm looking at domain. Domain is telling me all possible x values. I look at this and I think this is a discrete function. And so now I'm thinking I need it to be clear separation of points. It is not going to be this answer. It is not going to be this answer. Next, start looking at my x values. There is an x value of -2 from this guy. There's an x value of -1 from this one. There's an x value of 1 from this one. There's an x value of 5 from that one. And there's an x value of 6 from this one. So I'm looking for a set that has -2, -1, 1, 5, and 6. Looks like this. Okay, maybe you're getting the hang of it. And that is all. So what we just did was take a look at, I believe, 7 different problems. What I would like you to do now is to go to domain and range of a function on Khan Academy. So far, 7 students from all of my Algebra 1 classes have tried domain and range of a function. Only one of them has gotten 100%, and that one student has not tried IXL math yet. So I want you to remember that if you feel like you've already done this or you've gotten an A+ on it, if you're that one student that did, you could come to IXL math and try any one of these that I have starred for you. So you probably got an email and your email said, you've been invited, here's a username and password, go to IXL math. You can try domain and range of relations, which are groups of ordered pairs, or any of these other thoughts that we'll eventually get into this 4th quarter. If you go to Schoology, what you'll notice is that I have this IXL math link right here, and then your email gave you a username and password. Here's your Khan Academy link, and probably by later this afternoon, all of this stuff will have gotten shrunk up into a folder, and then you'll see this video down below. So happy Monday. Don't forget to come back here Tuesday for a live video lesson of domain and range of a function. All of that can be seen on this schedule. So right now, you just got your new lesson posted to Schoology on Monday, and then this will either be Zoom or probably going to be Google Meetup. I don't think the school wants us using Zoom for some reason. So from 1 to 2 p.m. tomorrow, I would invite you to come back and you can have a live video chat with me about the Monday lesson, which you just saw, domain and range of a function. Okay, well, please also notice that there is a lot of different videos that I have posted to Khan Academy. You don't have to click on those. It's your choice. What you are responsible for now is this, domain and range of a function, and you can see not many people have tried it yet. Okay, that's it for today. Take care. Uh, Meet me here. Come to Schoology, and we'll have a live video chat on Tuesday. Bye bye.